Alright guys, in this video we're going to be talking about the prefixes and some of the questions that dealing with the prefixes. If you have a really big number or a really small number, you can write it using prefixes, and it's just an easier way of writing it when you're dealing with the small or big numbers. For example, if someone has this much money, okay, that many dollars. So, saying that 1,000,000,000 dollars is kind of a little bit inconvenient, and you can easily lose the track of zeros, and the listener can also lose the track of zeros. So, what's the better way of saying those? Well, since we got nine zeros there, it's going to be said it's got $1 billion in there. Okay, if you have six zeros, you say million. So million and billion is actually in a prefix, and you could use those anywhere. It doesn't really have to do with the money, even though billions, millions, thousands, a lot of time they are used for the money, but you can also use for like how many vaccine doses you have to make, like 1 million or 2 million, so that you're using the prefixes in those cases as well. Now, in chemistry and physics, some of the most common prefixes that you are going to be using. So let's talk about those. And some of those you may already know about. I mean, you have heard about those before. So let's start with the base, where it means it's just one. And if you go above the one or the base, you are going into the bigger prefixes. And when you're going below the one or the base, you're going smaller than one prefixes. All right, not necessarily negative, but just smaller than one prefixes. Um, so suppose the first one, and I do have these underlined. Underlined mean those are the most commonly used in physics and chemistry, but then you still have some other ones here and there. So the deca is the first one I have above the base. The symbol for deca is DA, and one deca is actually 10. All right, so another way of saying if I have one decameter, it's actually going to be 10 meters. All right, so deca could be used anywhere. I could have decagrams or um, decaseconds. It doesn't really matter. So kilo is obviously one commonly used prefix, and kilo symbol is going to be uppercase K. 1 kilo is actually 1,000 or 10 to the 3. So you want to make sure you're able to write those both ways. Okay, and a really good example is going to be 1 kilometer is equal to 1,000 meters or 10 to the 3 meters. Either way is going to be fine. And then you have a mega. Mega is actually the same as million. However, you don't really use million when you're trying to measure the mass of something or the length of something. You don't really say million grams or anything like that. For the science purposes, you use mega. However, 1 mega will have 6 zeros, so it's going to be 10 to the power 6. And then you have giga. Giga is actually the same as the billion. So 1 giga is going to be 10 to the 9 number in there. So another way of saying another way of saying if I have 1 gigabyte, or let's say 1 gigameters, it means I got 10 to the 9 meters in there. So the easier way to kind of get rid of the prefix, whenever you try to get rid of the prefix, just write down what that prefix magnitude is. Like if I want to get rid of the giga, you know that giga in terms of the magnitude means 10 to the power 9. So that's what you just write down there. Tera is kind of similar to trillion, and just kind of going back to the mega and giga, they are actually um, very commonly used in terms of the computer memory. So back in the days, a lot of times um, the computer memories came in megabytes. Now they're coming in gigabytes, but in future or even now, the big computers have the memories in terabytes. So this tera is going to be an uppercase T, and 1 terabyte is going to be 10 to the 12. It's got 12 zeros in there, so it's a very big prefix. Um, some of those prefixes you already know, and it doesn't really hurt if you know how many zeros are there. And a lot of times in the exams or even in the homework, you will be given those prefixes. But obviously, like I said, it doesn't really hurt if you know what kilo really is or what mega really is. Okay, so then going downward, so let's look at the deci. The symbol for the deci is D. Okay, and deci is the tenth, all right? So another way of saying 1 deci is actually going to be 1 over 10, all right? And a better way of writing 1 over 10 is going to be 10 to the power minus 1. So if I have 1 decimeter is actually going to be 10 to the minus 1 meters. All right, so that's an easier way to kind of get rid of that prefix by just writing 10 to the minus 1. And obviously, if you want to just kind of explore different ways of writing it, you can also write it as 1 over 10 meters. And obviously, if you just kind of solve that down, you could also write that as 0.1 meters. Okay, so that's your deci. And centi has a lowercase symbol lowercase c. 1 centi is equal to 1 over 100, or another way of saying it's going to be 10 to the minus 2. Okay, so if I have 1 centimeter, it literally means it's going to be 10 to the minus 2 meters. And another way of writing this famous conversion factor is 1 meter is equal to 100 centimeters. And it usually comes from the same format here. Like if I'm writing 1 centimeter is equal to 10 to the minus 2 meters, if I rearrange this, it becomes 1 meters equals to 100 centimeters. So it really depends which one really you want to use, and either one of those are fine. Okay, and to just kind of make this this conversion factor easily memorized, remember 1 metric ruler has 100 centimeters in there. Okay, then you have milli with the lowercase m, and milli is going to be 10 to the minus 3. Okay, and then you got micro. Micro, well, we already used lowercase m and uppercase m. We used lowercase m for milli. We used uppercase m for mega. So that means we have to have another symbol that's going to be actually just this Greek letter, and it's just called micro. So 1 micro is going to be 10 to the minus 6. Okay, milli is used in medicines, like a lot of medicine comes in milligrams. Micro is used in microbiology, so the length of the cells and the organelles that we have inside the cells is in the order of micrometers, so that's where that term comes from. And then nano, obviously we're kind of dealing with nanotechnology these days, and nano is even a smaller prefix. The wavelength is measured in nanometers when you learn about electromagnetic spectrum. So 1 nano is equal to 10 to the minus 9. And then pico is the last one, a lowercase p. 1 pico is going to be 10 to the minus 12. So you want to be really, really familiar with the one I have underlined because those are the most commonly seen. And let's see how you actually really use those. So let's look at a couple of these questions here. So assume you have 20,000 milligrams and it needs to be converted to the megagrams. Now, if it's me, I can actually directly convert the milligrams to megagrams. But when you're trying to learn it, you want to look at the base unit. So in this particular case, the base unit is the grams. So your your plan should be, I want to get rid of the milli and convert it to the grams because that's what the base unit is. And then from the grams, I want to go back to the megagrams. So all I'm really doing here, going from point A to point B, is changing the prefixes. So before I have a prefix of milli, and then I have a prefix of mega. So that's why you also have to be a little bit familiar with what the symbols are for those prefixes. So uppercase M is for the mega and lowercase m is for the milli. Okay, so you have the plan laid out how you're going to go from point A to point B, but then let's write down the conversion factors that you're going to be using here. So you know 1 milligram is going to be equal to how many grams? Well, remember, the milli is actually 10 to the minus 3, so it's going to be 10 to the power minus 3. So that's one conversion factor. And then what's the conversion factor between the grams and megagrams? Well, 1 megagram is going to be how many grams? Well, remember the mega is just 10 to the 6, so that's what you're really doing there, replacing the uppercase m with 10 to the power 6. And those two conversion factors will be used here to figure out your milligrams to megagrams. Okay, so let's just go ahead and write it out now. So we got 20,000 milligrams to start out with. Okay, so then in the first step, I'm trying to go to grams, so I'll put the grams on the top. And then I'm trying to get rid of the milligrams, so I'll put the milligrams on the bottom. All right, so that's your first equality. And since you already have written down the conversion factor, all you really have to do is just plug in the numbers now. So you know 1 milligram is actually going to be 10 to the minus 3 grams. By doing so, the milligrams cancels out. Now you are at the grams. In the second step, we want to change the grams to megagrams. So I want to have megagrams on the numerator, and we want to have the grams in the denominator. Okay, and then go ahead and fill in the values. Remember, 1 megagram is going to be 10 to the power 6 grams. So that cancels out as well. So when you do this math, you got 20,000 times 10 to the minus 3 times over divided by 10 to the power 6. So this is actually, when you do all this math, is going to come out to be 2 times 10 to the minus 5 megagrams. Okay, so since you have only one sig fig in 20,000, you want to make sure you keep only one sig fig, and it's going to give you 2 times 10 to the minus 5 megagrams. And to easily do this, calculation in your mind, you can also say it's okay. We've got 20,000 times 10 to the minus 3 times 10 to the minus 6. When you bring this 10 to the power 6 from the denominator to the numerator, it becomes minus 6. So these two collectively will make 10 to the minus 9. And then this 20,000 could be written as 2 times 10 to the 4 because it's got 4 zeros. So when you just do this part, 4 minus 9 is going to give you minus 5 at the end of the day. So that's one way of doing the calculation if you don't have the calculator. And obviously if you have the calculator and if the numbers looks a little bit crazier than this, then you can use your calculator to do the math here. Okay, let's look at the second one here. We got 0.0045 kilometers needs to be converted to the centimeters. So the plan is we want to have kilometers needs to be converted to the centimeters. And I don't know the direct conversion factor between the kilometers to the centimeters, but I do know the kilo and the centi here, they're both the prefixes. So that means your base unit here is going to be the meters here. So maybe go ahead and convert kilometers to the meters first, and then from the meters convert that to the centimeters. All right, so always be able to identify your prefixes and be able to identify your base unit there. Okay, so what's the conversion factors going to be? Well, 1 kilometers is going to be equal to 10 to the power 3 or 1,000 meters, because remember kilo is just 1,000. And then also remember 1 centimeter is going to be equal to 10 to the minus 2 meters. Okay, so that's one way of writing it. And the other way of writing it, you can also write as 1 meters equals 100 centimeters. So either one of those equalities is going to be okay when you're using them in the calculations. Okay, so now you know how you're going to go from point A to point B. So let's just go ahead and write it out now. So you got 0.0045 kilograms to start out with. And then in the first step, we're trying to go to meters, so I'll have meters on the top. And we're trying to get rid of kilometers, so that needs to go on the denominator. And then just go ahead and plug in the numbers. So 1 goes with the kilometers, and 10 to the 3 or 1,000 goes with the meters. By doing so, kilometers cancels out, and now you can convert the meters to the centimeters. So since we're trying to find the centimeters, that goes on the top, and meters we need to get rid of, that goes in the denominator, so meters cancels out here, and then you can go and plug in the numbers. So if I stay consistent with how we have been writing all the prefixes, 1 centimeter is going to be equal to 10 to the minus 2 meters. Okay, so at the end of the day, your answer is here is going to be only in centimeters. So when I do this math here, it's going to be, well, I'm just doing this math in my mind. So this 4.0045 is going to be 4.5 times 10 to the minus 3. I'll be able to convert the decimals into the scientific notations quickly. And then I have 10 to the 3 already coming from the from the first conversion factor. And then this 10 to the minus 2 could be written as 10 to the 2 when it goes on to the top. Okay, so just add up all the exponents there. So minus 3 plus 3 and plus 2 is just going to give you 2. So that means it's going to be 4.5 times 10 to the 2 centimeters. So since you have only 2 sig figs there, that's how many you want to keep in there. That's one way of writing it. If you want to write it as in a whole number, you can just also write it as 450 centimeters. So either one of those ways are fine writing as an answer. All right, so make sure you know how to convert from one prefix to another prefix. It's a very common question. If you have any questions on any of those concepts, feel free to leave in comments.